Question number 17 asks for the chemical formula of sodium sulfate. Now notice that sulfate ends in ate and it doesn't end in ide. Whenever we have a chemical formula that does not end in IDE, that indicates the presence of a polyatomic ion. Polyatomic ions are found on reference table E. On table E we find sulfate, and the formula for sulfate is SO4 with an oxidation state of -2. Now sodium, element number 11, has an oxidation state of +1. Recall that when writing chemical formulas, we write the symbols with their oxidation states. Then we cross the number, not the sign. So that means that we require 2 sodiums and 1 sulfate. So choice B is the best choice. In question 18, we are asked to find the correct formula for nickel 2 bromide. Recall that in the stock system, the Roman numeral is exactly equal to the oxidation state. So the chemical symbol for nickel is Ni, and its oxidation number is +2. Now, bromide refers to bromine. Bromine, Br, has an oxidation state of -1. On our periodic table, bromine actually has several oxidation states. If the first oxidation state is negative, we always use that oxidation state. And recall, when writing a chemical formula, we cross the number of the oxidation state, not the sign, to the adjoining element. So in this case, we require 1 nickel and 2 bromines. Choice B is the best choice. In question 19, it asks which compound contains only 2 elements. So we begin with potassium hydroxide. Potassium is element K, and hydroxide is found on reference table E as a polyatomic ion. So potassium hydroxide has 3 elements. Now magnesium sulfate contains magnesium, and sulfate again is found on reference table E. It is found here. It's an SO4. So when I write out the 2 parts of the formula, again we have 3 capital letters. Choice C asks about aluminum oxide, so that contains aluminum and oxygen. And then our last choice, ammonium chloride. Ammonium is found on reference table E as NH4 positive. And so we have ammonium and then chlorine. So that has 3 capital letters. So the only formula that has just 2 capital letters is choice C. Question 20 asks which can be decomposed by a chemical change. If you can be decomposed by a chemical change, then you must be a compound. And compounds are not elements, or are formed of elements. And elements are listed on reference table S. Looking on reference table S, beryllium, boron, and magnesium are all elements, but methanol is not listed, so methanol is a compound. Question 21 asks about a compound that substance that cannot be decomposed by physical or chemical means. Recall that substances that are decomposed by physical means are mixtures, and substances that are decomposed by chemical means are compounds. So if it's not a mixture or a compound, then it must be an element. Recall that a solution is just another name for a homogeneous mixture. Question number 22 asks about a mixture of sand and salt and water that is stirred until all the solids have dissolved. So here the key word is dissolved. So anytime we have everything that is dissolved, that is synonymous with a homogeneous mixture. So Heterogeneous mixtures, things don't dissolve. Think about oil and water. It's heterogeneous because the oil does not dissolve into the water. Now, homogeneous mixtures can never be separated by a filter because if everything is dissolved, it will all just simply come through the filter. Question number 23 is similar where it's asking about homogeneous mixtures. When things are dissolved in water, they are left with the chemical symbol AQ, meaning in aqueous, which is in water. Think agua. Question number 24 is a heating curve, and it asks which segments represent an increase in average kinetic energy. Now we should underline average kinetic energy and recall that average kinetic energy is equal to temperature. So here they're just looking for an increase in temperature or an increase in Y. So the segments here circled all have an increase in Y. So choice B is the best choice. Question number 25 asks about which Kelvin temperature appropriately represents the equilibrium. Now, equilibrium means that we have both substances at the same time at that exact temperature. Now, here they give all the temperatures in Kelvin, and although Celsius to Kelvin temperature conversion is really easy, we should probably just write down the Celsius temperatures first. So ice-water equilibrium, that's the temperature at which water freezes or ice melts. That is 0 degrees Celsius. Now, so we will write that, and then the steam-water equilibrium in Celsius is exactly equal to 100 degrees Celsius. Now, in order to make the conversion, we're going to refer to our reference table, Table T. On reference table T, we can see the temperature conversion formula is the Kelvin temperature is equal to the Celsius temperature plus 273. So if we apply the formula to the question, let's see what we get. So in the first choice, we can see that these are not a match, so this is not correct. In the second choice, again, no match. In the third choice, no match again. And in the fourth choice, 373, we have a perfect match. So the fourth choice is best. The final question here, we are asked when ammonium nitrate dissolves in water, the water temperature decreases. When sodium hydroxide dissolves in water, the water temperature increases. So they asked us to describe the dissolving of these substances in water. Now we can do this one of two ways. We could just refer to our understanding of endothermic and exothermic. Recall that in endothermic reactions, heat goes into a substance versus exothermic, heat goes out or it exits a substance. But the best way to answer this question is to double check and use our reference table. In this case, references to endothermic and exothermic can be found on reference table I, like I love ice cream. Here on reference table I, we want to look up the dissolving of sodium hydroxide and ammonium nitrate. So I've circled these two processes, and then I've gone and the next step is to make sure you read and understand the table. At the bottom of the table, there's this asterisk that says that the H values are based on molar quantities represented in the equation, and the minus sign indicates an exothermic reaction. So when we look at the process for sodium hydroxide, we see that we have a negative, and when we look at ammonium nitrate, we have a positive. So sodium hydroxide is negative exothermic, and ammonium nitrate is positive or endothermic. Now, hopefully this makes a little bit of sense. So when the sodium nitrate was placed, When the ammonium nitrate was placed in water, the water temperature went down because the heat went out of the water into the ammonium nitrate. And when the sodium hydroxide was placed into water, the water temperature went up because the heat went out of the sodium hydroxide and into the water.